In this example, we've been asked to have a look at differentiating the following function. To differentiate this function, we are going to have to use the quotient rule. And we use the quotient rule when we have a function of the form u over v, where u and v can be functions of x, as they are in this case. So when we have a function of the form u over v, the derivative of that function is given by v du by dx minus u dv by dx all over v squared. So to actually calculate dy by dx for this example, we need to define our u, our v, and then from there calculate du by dx, dv by dx, and then substitute all of those values into our equation here to find our answer for dy by dx. So let's have a look at our example. We have y is equal to 2x plus 1 over 3x minus 2. Now u is always the numerator, the function on top. So let's define u as our 2x plus 1. V is our denominator, the function that's in the bottom of the fraction. So v in our example is 3x minus 2. We've defined our u and our v, so we've got our u and our v. We now need to find du by dx and dv by dx. So I've got my u, so I can just differentiate that to find du by dx. So if I differentiate 2x, I get 2. And if I differentiate 1, well 1's a constant. When you differentiate a constant, you get 0. So I could put in a plus 0 here, but that's not needed, so we won't bother. That's our du by dx. We also need dv by dx, so I need to differentiate 3x minus 2 with respect to x. So the first thing I need to do is differentiate 3x, and when I differentiate 3x I get 3. And when I differentiate minus 2, again minus 2 is a constant. When I differentiate a constant, I get 0. So I can see that dv by dx is equal to 3. So I've got everything now. I can now just substitute our u, our v, our du by dx, our dv by dx back into our quotient rule. So our quotient rule tells us that dy by dx is equal to v du by dx minus u dv by dx. So let's put those values in first. So v is 3x minus 2, and I'm putting all that in a bracket, multiplied by du by dx. So du by dx is 2. Then I have minus, then u, so it's going to be minus 2x plus 1, multiplied by dv by dx, which we found to be 3. So that's our numerator done. And then what do we have on the denominator? We have v squared. And v was 3x minus 2, so I'm going to write that as 3x minus 2 in a bracket, and then square the whole thing. That's essentially everything done. That is our derivative, that is our dy by dx. It looks a little bit messy, so we need to tidy it up a little bit. Now, the general rule is to leave the denominator alone. Never expand it out, just leave it in the form it's in, and expand and simplify the numerator. So let's do that, let's see what we get. So the first term is 3x minus 2 times 2. So if I multiply that out, I'm going to get 3x times 2, which will give me a 6x, and then a 2 times minus 2, that will give me a minus 4. Then I have minus, I'm going to leave that minus there for now, and do the expansion of 2x plus 1 times 3, but leave that in a bracket. So what will I get there? I'll get 3 times 2x, which is 6x. And I'll get 3 times 1, which just gives me 3. remember all of that is over this 3x minus 2 squared. So we've expanded the top. We still need to simplify it a little bit further. We can't do anything yet with these first two terms, so I'll leave that as 6x minus 4. But I have minus this bracket containing 6x plus 3. Now this is an important step. This is a common mistake that we see. This minus sign is acting on both terms in this bracket. So the minus sign is acting on the 6x and it's acting on the plus 3. So it'll be minus on the 6x, so that'll give us a minus 6x. And then the minus is acting on the plus 3, so that will give us a minus 3. All over is 3x minus 2 squared. And our last step is just to simplify the numerator once more. What can we see? Well, we can see we have 6x and a minus 6x, so they've cancelled each other out. And we have minus 4 and a minus 3. Now minus 4 minus 3 gives us minus 7. So we can see our final answer is going to be minus 7 all over this 3x minus 2 squared. And that there is our answer for dy by dx.